All right, so get this. Today's deep dive is about AI, but with a twist.
Okay.
You guys sent in 2 articles on this year's Nobel Prize in Physics,
Right.
which went to John Hopfield and Geoffrey Hinton.
Yeah.
And the connection to AI is, well, let's just say it's pretty mind-blowing.
It really is fascinating how these two fields, physics and AI, which seem so different at first glance,
Right.
are actually intertwined in such a profound way.
Totally. We're talking about like atoms inspiring algorithms.
Exactly.
So John Hopfield, let's start there.
Okay.
What was his big breakthrough in this whole AI world?
Well, you see, his work is truly groundbreaking.
Okay.
Back in 1982, he proposed this really radical idea.
Okay.
What if we could apply the principles of magnetism
Oh, okay.
to how artificial neural networks operate?
Oh, okay.
Yeah.
Yeah.
It might sound strange,
Yeah.
but his deep understanding of theoretical physics allowed him to make these unexpected connections.
So magnets were like the inspiration for some of the most advanced AI today.
That's one way to put it.
Yeah. I mean, how did he even begin to connect those dots? Magnets and AI.
Well, he realized
Yeah.
that both magnets and neural networks share a fundamental principle.
Mm-hmm.
They both naturally seek out the lowest energy state.
Right.
So think about it. In a
Yeah.
magnet, the atoms align themselves in a particular way to minimize energy, right?
Right.
Hopfield realized that a similar principle could be applied to artificial neurons in a network.
Oh, okay.
Yeah.
So instead of physical atoms, we're talking about these artificial neurons.
Yeah.
And they're acting like tiny magnets,
Yes.
all trying to find the most stable configuration.
Exactly. They kind of settle into a state that represents a memory, much like a physical magnet settles into a particular magnetic orientation.
Okay, so that's where his concept of associative memory comes in.
Precisely.
Okay, so is that like, I don't know, when a word is on the tip of your tongue,
Yeah.
but all you can think of is something that kind of sounds similar?
Yeah, that's a great analogy. Like when you're trying to remember a word, let's say rake.
Yeah.
But all you can come up with is like radial.
Yes.
Your brain is doing this associative search,
Okay.
trying for the closest match.
Huh.
And Hopfield networks, they work similarly.
Interesting.
They store patterns.
Okay.
And even with incomplete information,
Yeah.
they can find the closest match.
So that's how, like, voice assistants can understand us,
Exactly.
even with background noise.
Yes,
They're searching for the closest match based on what they've learned.
precisely. Or think about like image recognition,
Okay.
working with a blurry photo.
Yeah.
That's associative memory at play,
Wow.
coming straight from Hopfield's insights into energy states.
So this energy landscape idea,
Yeah,
it's pretty abstract, I gotta say.
it is. It is.
Can you, like, paint a picture for us? What does that even look like?
Okay, so imagine a ball
Okay.
rolling down a hill.
All right, I'm with you.
It naturally seeks the lowest point, right?
Right.
The valley.
Right, makes sense.
Now that valley, that represents a stable state.
Gotcha.
And in a neural network, that would be a stored memory.
Okay.
The whole landscape, the peaks, the valleys,
Yeah.
that represents all the possible energy levels within the network. The network, it wants to be in the lowest energy state.
Okay.
So it adjusts itself based on the input it receives.
So it's like the ball rolling downhill trying to find that lowest point.
Exactly.
So Hopfield created this model where AI could, like, mimic our brains
In a way, yeah.
in how we store and retrieve information, all based on these, like, energy landscapes.
You got it. And his work, it wasn't just theoretical.
Right.
No, it had real-world implications.
Interesting.
Made these complex neural networks easier to understand.
Okay.
Opened up all these new paths for research.
That's amazing.
And that's where Geoffrey Hinton enters the picture.
Okay, so Hopfield laid the groundwork.
You could say that.
So what did Hinton bring to the table?
Well, he was totally fascinated by Hopfield's work,
Makes sense.
but he saw an opportunity to
Wow.
take it even further.
Also.
He turned to a branch of physics
Okay.
called statistical mechanics.
Statistical mechanics.
Yeah, which deals with systems made up of
Yeah.
many, many particles.
Lots of particles.
Tons of them.
Like microscopic level here.
You could say that.
Okay.
I know it sounds complicated, but the connection to AI is fascinating.
Okay, I'm listening.
Think about trying to predict the weather.
Okay.
You're dealing with countless air molecules,
Right.
each behaving differently.
Yeah.
Statistical mechanics helps us make sense of all that complexity.
Okay.
And Hinton, he realized he could apply these same statistical methods
AI.
to artificial neural networks.
Wow.
And this led him to develop something called the Boltzmann Machine.
The Boltzmann Machine.
Yes.
Okay, that sounds important.
It is.
Tell me more.
It's named after Ludwig Boltzmann,
Okay.
a brilliant physicist known for his work in, you guessed it, statistical mechanics. And the Boltzmann machine, this was a huge leap forward because it introduced this groundbreaking concept.
And what was that?
Hidden layers.
Hidden layer.
Hidden layers within a neural network.
Okay, now you've got my attention.
Fs.
What are they and what makes them so groundbreaking?
Great question.
Yeah.
In the Hopfield network, everything was directly connected.
Okay.
But the Boltzmann machine,
Yeah.
it added these intermediary layers of neurons, the hidden layers, between the input and output.
Okay.
And these layers, they allow for the modeling of much more complex relationships within data.
So instead of just direct connections,
Right.
it's like the AI has like detectives working behind the scenes,
Lasso like that.
finding clues and connections that we might miss.
Exactly. It's like giving the AI a deeper level of understanding.
Ah.
Imagine trying to grasp a complicated concept.
Yeah, okay.
There are often hidden connections and layers of meaning that aren't immediately obvious, right?
Right.
The Boltzmann machine, with its hidden layers,
Yeah.
could start to uncover these nuances within data.
Wow. This is incredible.
It is pretty
So
amazing.
it's like we're going from like simple pattern recognition to something resembling actual understanding.
And you know what's even more incredible?
Right.
This innovation paved the way for something we're hearing a lot about today. Generative AI.
Okay. Yeah.
Think AI that can create new images,
Right.
write text, or even compose music.
Wow.
Yeah.
Generative AI.
It is remarkable.
That's where it feels like we're living in the future.
Right.
It's like AI is becoming an artist
Yeah.
or a composer.
It really is.
That's wild.
These AI art generators that are out there, even AI writing code,
Right.
it all stems from this idea of the Boltzmann machine being able to generate new data points
Okay.
that resemble the data it was trained on.
So instead of just recognizing a pattern,
Right.
it can create something new
Yes.
based on those patterns.
Exactly. But how, it's tough to say.
Yeah.
Because we can't really peer directly into the mind of a Boltzmann machine. But those hidden layers, they allow it to learn much more intricate representations of data.
Okay.
It goes beyond just simple associations, you know?
Okay.
The hidden layers can pick up on these subtle features, these relationships that we might completely miss.
So it's almost like giving AI a form of intuition.
That's a great way to put it.
Wow.
Yeah, it's about moving beyond memorization
Okay.
to a deeper understanding of the underlying structure of information. And that's what allows it to create something new
Okay.
that still fits within the rules and patterns it's learned.
This is really making me appreciate how these physics concepts
Yeah.
from decades ago
Yeah.
are having such a huge impact today.
Totally.
But, I mean, there must have been other advancements
Oh, absolutely.
that kind of bridge the gap between this early work
Yeah.
and, like, the AI boom we're seeing now.
Of course, it wasn't an immediate leap,
Right.
but Hopfield and Hinton's work
Yeah.
absolutely laid the foundation for what we now call deep learning, which is really the driving force.
That's so interesting, deep learning.
Yeah.
Is that, like, where the name for this podcast came from?
Oh,
I'm just
well,
saying.
I can either confirm nor deny that.
Okay, fair enough.
But,
But seriously, deep learning,
yeah.
what is it exactly?
Well, think of it this way.
Okay.
You know those hidden layers we were talking about?
Yeah.
Instead of just one or two.
Yeah.
Imagine dozens,
Okay.
even hundreds of these layers,
Wow, okay.
all stacked on top of each other.
Right.
That's essentially what deep learning is.
Okay.
These large, multi-layered neural networks.
So the Boltzmann machine was like
Yeah.
a small scale model.
Like a prototype, almost.
Okay.
Yeah.
And deep learning just like
Took that
took it,
and ran with it.
scaled it up massively.
Saved it up massively, exactly.
Okay, got it.
And with that added complexity,
Yeah.
deep learning models can tackle incredibly complex tasks.
So that's like image recognition that actually works.
Exactly.
Natural language processing,
Yes.
self-driving cars. This is all
It's all powered by deep learning.
mind-blowing.
It's pretty amazing.
It all goes back to those initial physics principles.
It really does.
Minimizing energy,
Right.
modeling probabilities.
Exactly.
It really highlights how interconnected things really are.
It's a fantastic example of the power of interdisciplinary thinking.
Right.
Hopfield and Hinton took these concepts from a seemingly unrelated field
Right.
and used them to solve a problem no one had figured out before.
Yeah.
They opened up a universe of possibilities.
It's like they discovered a secret passage. However many don't put it.
between two different worlds.
Right.
It makes you wonder if physics was the unexpected catalyst for this whole AI revolution.
Yeah.
What other fields could hold the keys to the next big breakthrough?
That's the million-dollar question.
Right.
And it's a question we should all be asking ourselves.
Seriously.
Are we talking philosophy? Biology?
Possibly.
Maybe music theory will unlock the secrets of AI consciousness.
Who knows?
Right.
It's impossible to say for sure.
Yeah.
Perhaps the key to truly sentient AI
Yeah.
lies within the principles of quantum mechanics.
Okay.
Or maybe there's a field we haven't even begun to explore yet that holds the answer.
This is giving me a lot to think about.
It's a lot to ponder, for sure.
What's like the most important thing
Yeah.
you hope our listener takes away from this deep dive?
For me,
Yeah.
the biggest takeaway is that we should never underestimate the power of seemingly unrelated fields to influence each other.
It's true.
Who would guess that physics would play such a pivotal role
Right.
in the evolution of AI?
Nobody.
Exactly.
It really underscores the importance of cross-disciplinary thinking
For sure.
and being open to the unknown.
Absolutely. That's where the magic happens.
It's a good reminder to just never stop being curious.
100%.
Right.
Keep asking those what-if questions.
Yeah.
And don't be afraid to explore the unknown.
Yeah.
That's where the real breakthroughs happen.
It's like that saying, if you want new ideas, read old books.
I love that.
Maybe we need to like brush up on our quantum physics or finally take that philosophy course
Exactly.
we've been putting off.
Why not?
Right.
It certainly couldn't hurt.
No?
And who knows?
Yeah.
It might spark the inspiration for the next groundbreaking discovery.
This deep dive has really, I don't know, it's really opened my eyes
Yeah.
to how interconnected things really are, you know?
It is amazing to think.
Like, who knew
Yeah.
that something as seemingly abstract as, like,
Yeah.
the study of energy in physics could revolutionize the way we interact with information?
Absolutely.
It's wild.
It really is.
And to think, this all started with a physicist
Yeah.
basically being like,
Yeah.
what if neural networks are kind of like magnets?
That's essentially what sparked it. Yeah. It's amazing. It really speaks to the power of just asking those what-if questions.
It does.
Right.
It reminds us that the most groundbreaking discoveries
Yeah.
often come from unexpected places.
Totally. Like nobody would have seen that coming.
Right.
You know?
Exactly.
It makes you wonder what other hidden connections are out there,
Oh, I'm sure there are more.
just waiting to be uncovered.
Absolutely.
Right. What seemingly unrelated fields
Yeah, who knows what's next, right?
might hold the key to the
Yeah.
next AI breakthrough.
Exactly. It's an exciting time
It really is.
to be exploring these questions.
It really is. So
Yeah.
if our listener takes away just one thing from today's deep dive,
Okay.
what should it be?
For me,
Yeah.
never underestimate the power of curiosity.
Okay.
Keep asking those what-if questions.
I love it.
And don't be afraid to explore the unknown,
Uh-huh.
because that's where the real breakthroughs happen.
Well said. And on that note,
Yeah.
we'll wrap up this deep dive.
Into the fascinating world,
It has been fascinating.
where physics supercharged AI.
Absolutely.
Until next time,
Yes.
keep those what-if questions coming.
100%.
See you later.